Hello my dear friends, welcome to Inside Electronics channel. This is Uncle Misha and today we have the Simpson 260 super old school multimeter or milliampere or ammeter because it measures DC, AC, voltage and currents and also resistance. Am I right? You see it here probably resistance. So it has different ranges. It has ohms range, it has DC range, it has AC range, and it also has dB range. So we don't really know if this is like averaging multimeter or VTVM or something like that. Not multimeter, voltmeter, because I haven't found the service manual for this guy. Also, I haven't found the schematic. So what we're gonna do, first of all, we're gonna try if this operates, but I definitely know that it doesn't, because one of my videos I tried to measure something and which is like not AC, not DC, and clearly not resistance, because for resistance you need to have battery. So I'm not really even sure if this thing has battery, but if it has battery, what condition that battery is. So yeah, so what are you gonna do? You're gonna try to do some basic measurements using this common and plus, like for example, measure the battery voltage, okay? But I'm telling you right away, it's not gonna work. But let's try, let's do it. What's kind of cool about this multimeter, it still uses 4mm plugs, not some kind of old school 3 or 2mm as far as I remember. So yeah, it's not the best probes I have, but like it's because the other probes, like for example these guys, they are shrouded, so I won't be able to use them in this multimeter. Okay, so okay, so we switched to 2.5 volt DC range, and see what's gonna happen here. It's nothing. Okay, let me see, maybe it's bad battery, I don't know. Nothing, absolutely nothing. So yeah, it's not working, unless I don't know how to use it. All right, but okay, let's do my negative DC. No reaction, 500 milliamperes. No, we don't need that. Okay, let's switch to, I don't know, let's switch to like 5000 volt DC. It's just not, like, because I don't really know. Well, I assume this is the common and plus. I'm not sure what this output. Yeah, definitely need the service manual and manual for this thing. But nevertheless, it's still, no matter what, even if this thing is half operational, let's do 10 volts, you still have to show something. Yeah, it shows nothing really. So yeah, we need to take a look what is going on inside. So it has 4 screws flat. Ooh, not often you can see that. Find my flat screws here. Screwdriver, I mean, not screw. Yeah, here we are. So flat screwdriver. Let's just try to. So probably this is the time when Phillips wasn't the obvious choice for screwdrivers, right? I'm just curious, what kind of goodness we're gonna open up, see inside after we open it up. I would say this guy is, ooh, cool. Oh yeah, oh yeah. Oh, clearly it has the battery in here. I mean, obviously the volts range won't be two. What? It's 2 batteries? Oh man, I clearly need a service manual for this guy. Oh, look at this, it's falling out. Like a little piece of paper, which is like an insulator. And there's capacitors right here. 600 microfarad 16 volt, which is parallel to this battery. It's not like how do you call it, a, oh, look at this beefy resistor. What, 80 mega ohm? Woohoo! You see this beast, 80 mega ohm resistor. This is amazing. Curious what kind of precision is here. It's looking actually pretty cool. So there is a potentiometer, zeroing potentiometer. There is a whole bunch of range switches, like this one is double gang range switch, I think. Yeah, there is two wafers here, one top and the bottom, so it's like, I think it's double gang. So this is single gang. 1, 2, 1, 2. It's like not much going on here. And okay, I have a little bit of news and investigation done. So what I found, so here is the schematic for this guy, and this guy, I thought, actually, it's maybe not the right schematic. Alright, so this was schematic for series AFP 1, and this one is series 5P. I don't know why they got confused. Let me get the correct schematic, but this is actually pretty close, just because this one photo, I didn't have it. It looked exactly the same as this guy and a similar layout, but the transistor jazz here is a bit different. The reason I kind of got into this, because there are many different variations of this how do you call it, multimeter. So there's like a lot of different variation, and they are quite different inside, and some of them uses different battery layouts. So this particular guy uses D cell right here for 1.5 volt, and turned out to be, this is not what I thought it is. This is, it says here, B2, battery 2, 15 volt battery. So I'm gonna double check this specifically with series 5P, just to make sure this is not something else. But it's not, it says nothing here, right? It says completely, like absolutely nothing here. Plus there is also no polarity, kind of like you can walk the battery like the way you want it. And the same for here, like it says nothing. It says what, 385, I'm not sure what is that, serial number maybe. There is no information on the back here at all. So yeah, how do I supposed to know what it is? Well, except it says right here, series 5P. I actually checked series 5, and I thought it looked different. So maybe there is a 5P series, which is actually how the way that looks like it's supposed to be. So let me get the right schematic, I'll be back with you. So I got some schematics, and they are super bright, but I think they are visible. So this is schematic from Model 260 series AFP1, and this is schematic for Model 260 series 5P. And looks like they are pretty much identical, and still slightly different from this guy, because this one is 5P. Why different? Because look at this this part over here. So it here has two transistors, two resistors kind of arrangement. On this board we do not have two transistors anywhere else, so this is a single transistor setup. So I'm not really sure what's going on here. Potentially there is a variations of this. I didn't check anything else, but at least some of the things, like for example this 20.2 mega ohm and this over here 80 mega ohm resistors are correct, like whatever, you know, jumps at me right there. Some diodes are the same and things like that, so potentiometers are the same. So anyways, very interesting things what I found, that this thing requires two batteries. One of them is 1.5 volt, which is going to be, I think, D cell right here, and another one is this, and it is 15 volt, which is crazy. So 15 volt battery, this is something I never heard before, and obviously you can find, I don't remember where actually I saw I saw somewhere where it actually says what the type of the battery. It's some kind of weird battery. I'm gonna write it here. I never heard it before. So, but like obviously it's pretty much unobtainium to get this battery, but I have an idea, and my idea will be, I'll show you. So here is my idea in a nutshell. This is IKEA 3-volt lithium batteries. In order to have 15 volt, we need 1, 2, 3, 4, 5 of these guys stacked together. So this is 3-volt 2450 batteries, and I have 5 of them precisely for 15 volts. This is 1632 batteries, 3-volt. So I need 1, 2, 3, 4, 5 stacked together in a sandwich. So let's me see what gonna go. Oops, where is that? It's gonna go nicely here. Wow, so it looks like even these big guys can actually fit nicely. The question is, do I need that much energy? Because this I don't know what's the capacity of this particular battery, unfortunately. But this one is beefy one. Like I have 2 packs of them. Oh, actually, I mean I used one for one of the Wise sensors. Well, it's old tech now, but so these IKEA guys, they may work here potentially, you know. But I'm gonna just pull one out. But look at this, it's a beefy one. I don't know the polarity, this is another problem. I don't know what kind of genius. But thank you for this capacitor, so this is negative. Oh wow. So there are a few ways I can do it. I can develop a 3D printable holder, which actually holds 5 of these gentlemen right here, either of these gentlemen or these gentlemen. So this battery is obviously the most expensive, but it's still not as expensive as buying that ridiculous 15-volt battery. The cheapest is this. You can go to IKEA, you can buy a shitload of them and be not a problem. So 5 of these batteries will go for 16 millimeters. So that's gonna be the stack of this batteries will be pretty small. Okay, so this guy is gonna be a little bit thicker, but still relatively small. So yeah, you can use either or. And I totally can MacGyver some kind of contraption which actually put 5 of these or 5 of these in there. So let me think about that in the meantime, because probably for continuation of, oh, by the way, there is another difference I forgot to mention. This capacitor is not present on not any of these schematics, and for this cell I can use any kind of regular battery inside this contraption, or you can 3D print something. It's super easy. So this is good to go. This I have to design. So probably I will design this first, manufacture it, and probably gonna use these ones because they are the cheapest and easier to get in IKEA. And then we will continue, because I think without those 2 batteries, it's very hard to understand if this thing is working. Alright, so I have some progress with the battery compartment for replacement of this ever-ready 417 battery. So I think you got the idea, right? 5 of them gonna be sitting here, and these will be placed. Ooh, I think maybe I have to make it smaller. Right in here, right? And and then you'll see more. It's work in progress. Okay, maybe I have to really make it smaller. Think about it. Okay, so this is in work, being 3D printed and manufactured. It's just a super early prototype to explain the idea. Okay, let's go back here. What do we have to see? So first of all, I think we need to clean up all of those potentiometers. Deoxide them and things like that. And I think we have to clean up all of these switches, because I think this device is supposed to work without power. So if you want to measure voltage and want to measure a voltage, AC or DC, I meant to say, you don't need power. So the battery is for this batteries is for ohm range, okay, just to provide power to measure resistance, and this battery is for protection and for mega ohm range. So this range requires, or this range, I think this range, resistance by 10,000 require 15-volt battery. So any other range would work with 1.5-volt battery. Yeah, so before I continue, I would clean up everything. I pretty much would clean up these guys as well, because, you know, especially this high voltage one, if there is a crop of a sort here, high voltage just gonna, you know, dissipate energy in the crop, arc, and do all other bad things. We don't need that. Okay, so this is the idea. So I'm gonna clean up everything. I'm gonna use my deoxide to apply everywhere I could. You know, I won't be able to completely disassemble these potentiometers, because not the potentiometers, the board, at least not yet, because I don't think I need like any major repair here. As long as I don't need that. Wow, it's weird. So I think it's kind of hilarious. I'm not sure if this is good, but this thing was touching actually this shaft. I don't know if it's a good idea, is it? Those are just non-insulated wire. This is probably trimmed resistance for, this is like a current shunt, this guy, and it trimmed to a certain value. Oh no, yeah, this is just regular wire, sorry. No worries. So this guy was touching the shaft of the resistor, but potentiometer, I mean, which is resistor, variable resistor. But that's okay, never mind. So I do not see any obvious damage. Obviously gonna double check everything right in here. Yeah, I don't see any obvious damage, for example, burnt resistors or anything like that. So first, to understand what the heck is going on here, we would start with the clean up all these potentiometers, the switches and pods. We'll see how they gonna look like. These are weird trimmers, like these two and this one. Not sure how good are they, but they have to be cleaned as well. So let me do it. I'm gonna do it outside, because all these fumes and stuff, I don't want to breathe it in, especially keep it in the house. So I'll be back. Alright, so after application of this stuff outdoors, have cleaned everything, and let me see what else we can see. So there is also this fuse here. Let me check this fuse, because I sort of forgot about it. Who knows, maybe it's all gone, and that's why nothing works. Okay, let's take our modern multimeter here, switch to the... What's going on, my friend? Okay, fuse is fine. Fuse is okay. So if fuse is okay, let me see if this thing works after cleaning the contacts. So technically, in order to measure voltage, unless I'm misunderstanding how this thing works, we have to connect positive here, negative here, switch to plus DC, switch to 2.5 volt is good. Where is our battery? And nothing happening. No movement whatsoever. Yeah, something is not good. Maybe the movement is gone. If this thing is gone, like this is pretty much 95% of the whole unit, right? If this thing is gone, it's pretty much useless. So how do I actually go with testing the movement, or I don't know how you call it, not the dial or the meter, the meter itself. This is actually the meter. This is the meter, right? This is all just to get it. Okay, so far I'm puzzled. There's no voltage across this guy. So let me do the following. So let me check this battery. 1.5 volt. Let me do this. Unless I'm super duper crazy. Okay, so this is our cell. Positive. Okay, now let's disconnect this guy from the voltage. So we're not gonna apply voltage to the milliampere meter. Okay, we're gonna go to R1 mode, we're gonna short it, and nothing happens. So that's not good. Technically, if you do this, this is supposed to go into zero. Yeah, into zero, because the top line is ohms. Nothing happens. So and this is supposed to adjust 0 ohms. Yeah, looks like we have busted meter. Oh no, I had high hopes. Unless here is no contact, let me double check if there is voltage. 1.5 volt. No voltage here. So where did this 1.5 volt go? Okay, it goes into various modes and dividers. Alright my friends, actually MacGyver something here. If you remember from one of my videos, I had this resistive divider which is pretty handy to make different resistances. Those are multi-turn precision-ish potentiometers. So my idea is I'm gonna use my power supply set to 1 volt DC, and we're gonna measure some currents here. So microamps. Okay, we're gonna switch it to microamps. And what we want to do, we need to get 50 microamp, because what we see here, this meter movement is designed for 50 microamp full scale deflection, and it's, I guess, 1800 ohms, its approximate resistance. So we're gonna, first of all, let's see what we're gonna get with this current source, improvised current source. Okay, so we're gonna attach it to here, and we're gonna attach it to here. And we have 47 microamps. Okay, so we have 48 microamps. For example, I can adjust it. So it was a bad contact here, that's why it was finicky. Alright, so my idea then is to take apart this board and actually connect it straight to the meter movement. Why? Because I do think if there is some kind of shorted resistors here, they're gonna completely impede the movement of this thing. So I have to disconnect it from the board. In order to disconnect it from the board, I would have to disconnect it from here. So what you're gonna do, you're gonna actually unscrew those screws, unscrew that, and we're gonna see what we can reach. So I have extra alligator clip here. So this is gonna go straight on one of the pins of the meter movement. I'm gonna use this piece of paper as an insulation. Okay, just like that. Another one, let me see my 47. Another one. Okay, positive we'll leave it like this. So negative gonna go into the... doesn't really matter. So actually wrong. Positive gonna go here. And negative gonna be connected to this. Okay, looks like we have some movement and in the right direction. Oh, something impedes the thing. I'm curious what would be that. Is it this? Looks like something wrong here. Okay. Definitely something wrong with this thing. So we have to dig further. Now we have to actually completely remove the meter movement and take a look what's going on there. Because looks like we have an issue. So in order to remove the meter movement, we have to unscrew the faceplate. Okay, this is the faceplate. Now we have access to the meter movement, and I'm just curious if this is mechanically. It sticks here. Oh, now I see. What's the problem? Oh, it's magnetic. That's okay. That was bent. Right. Okay, let me put this. I don't know how this has happened, that this was bent, but this little thing is adjusting the 0. Okay, let me put back to 0. All right. Let's just repeat our procedure here. Insulation. Positive goes back to 50. And let's put this alligator back where it was. And so now we have to have some sort of... Yep. Well, it's not... It's 47 microamps actually, but we have full deflection. So this guy over here was impeding the movement of this thing. So this little a little thing has to be aligned like this, just to match that position, right? And someone probably was just fiddling with it and broke it. So you have to not fiddle with this too much. Okay, so that test actually gives me an idea that the meter movement actually deflects properly and roughly when it's supposed to be. I'm gonna adjust this to actually 50 microamps. I'm gonna adjust the meter movement properly using the compensation potentiometers that is there. But roughly, that's what it does. Okay, my friends, so let me check this theory about 1800 ohm here. So what I've done, I switched it to the kilo ohm range, and you have to make sure that you are in the right range. If you put ohms or a single digit of kilo ohms, it's gonna produce too much voltage and gonna pack the needle immediately. So you have to use the manual range on your multimeter to switch it. For example, like in my case is like 40 range. So now you see it's actually measures to 3 kilo ohms, but if I, for example, switch to 400 kilo ohms, you see it measures, but it barely deflects. But when I switch, for example, to 4 kilo ohms, look what's gonna happen. I'm gonna immediately, deflect the needle. So that's, if you switch it to ohms, it's gonna even fall stronger because voltage at ohms range is gonna be higher. Anyways, or current. The current is gonna pass through the coil. All right, so I think meter movement seems to be okay. Let me double check it again after poking these ohms. I hope it didn't break anything. Yeah, it deflects. So now I'm gonna put the top back on because I don't want to like mess this thing up while I'm fiddling with the electronic part. Let me double check if this adjustment is working. Yes, it does. Does it? Okay, let's try again. Yes, it does. It has to be super careful with this adjustment. Okay, let's leave it like it is. Let's secure the cover back. So we know that meter movement is operational, which is quite important. Essentially, it's the most important part. If this thing is not working, there is no point to continue this video. But now we know that there is a point to continue this video, that meter movement is okay. So now we have to find the fault elsewhere. So voltage range, AC or DC, is supposed to work without any batteries, right? Because it just converts the voltage into current and displays it on the voltage applied through resistors and converts it into some current which is going to be displayed in the meter movement. So that means that there's something in this, some electronic components, either shunts the meter movement or shorts, or resistance is super high. Well, I mean, all right, so that's gonna go back. So now we have to, maybe I'll just, so this is current shunt wire is interfering. I'm not gonna touch it actually for now. What else do we have here? Interfering. There are several wires which are sort of in the way, but yeah. So this resistor over here, I think it's a resistor, is actually unsoldered, but I don't think it would affect anything. So yeah, I can solder it back, obviously. I don't know why it's unsoldered. It's a really bad soldering job. But I don't think it's gonna affect anything because I was just holding it back, it didn't change. So there's a possibility that one of the resistors here on these dividers is bad. Okay guys, after poking around for a while, I figured out a few things. So number one, this big thing over here is a shunt, which is actually here on the schematics. It's a big shunt for the 10 amp range. So this, and it looks like it depicted as a potentiometer right here, just because it has this sliding kind of nut, and you can screw it and regulate and adjust the current. So I guess that's set for some specific value. I'm not gonna touch that. But this gentleman right here, whatever is unsoldered, is this gentleman. This is supposed to be 47 ohm resistor, which is connected to this shunt, which is, and it's at one end connected to this shunt, and it reads like 0.8 ohms or something to this extent. So this resistor is Gonski, but the problem is it should not affect anything else, because this is just specifically for milliamp range. So all this stuff not gonna work because of this resistor. So you have to put something here which is 47 ohms. We're not gonna touch that for now. We need to figure out what's going on with voltages, because voltages still do not work. So actually, since the last video, it was probably several weeks has gone, or not several, a few weeks has gone since I finished that sort of testing, and now I have something to share you. So here we are. I think we got into some kind of solution for ever ready for 17 type of battery. So I have a few iterations of these particular design, and I stopped at this one. So this is the bottom part of it where 5 3-volt batteries fits. This is the top part, which is actually has this like just regular copper wire. It's 2 pieces, one like this, another is like this, but technically you can just wind some wires, and 2 screw holes where you put 2 screws. So you do like the following thing, and you have your battery. You just attach top to bottom, screw this in, and the battery is ready. Just as simple as that. Obviously gonna be a little bit of gap here because of the wire. It can be a little bit better designed in terms of like, oops, not the right one. Let me measure the voltage, and obviously it's gonna be a little bit higher than 15 volt. What do we have? 15 point, yeah. So yeah. So some of the one of the batteries here, I think is a little bit used already. So 5 3-volt batteries. So, and this fits nicely right here. So by my calculation, thanks to this capacitor, this is negative, this terminal, and this terminal is all over here, and here is positive. So this is our negative, bottom of the 18650, 2032, and this is top. At first I wanted to use a screw, just screwed in here, but just didn't need to. So here we are. And how do we test that this thing is working? Well, ideally, if this thing would work properly, we would use the short common and what was that? Oops, probably scratched something. It was a weird noise. And the movement would go like here in this mode, or actually essentially in any other mode, but in particularly in this one, we use meter movement to put the 0 ohm, because in any other mode, while this battery is present, it's still gonna do deflection, complete deflection to 0 ohm when you short leads right here. But specifically in this mode, this battery will kick in, and the this is how you adjust your 0, which is, by the way, Nobi is missing. All right, so but now we have a problem that we need to figure out what's going on with the meter first to see if it's operational, and I will continue troubleshooting. Okay guys, so after poking around for a while, I finally understand how this thing's supposed to be working. After I installed my MacGyver a 15-volt battery right here, yeah, it's very hard to demonstrate. Yeah, it's because you can barely see, and to remove this top I can't remove it, but in this case I will disconnect meter movements and it won't be showing anything. So let's see. You know what, I can actually take some shots, and I'm gonna be talking and showing you photos. Okay, so here we are. I've done some pictures. So here at the first photo we have a relay, and this relay is in normal condition is normally closed, right? So these 2 contacts that you see over here encircled, these are ground, common. So this is, it goes after the fuse. So okay, by the way, here is the schematic. Okay, so common, fuse, and the switch. So this switch is just the one I showed on the photo, right? It's connected to the relay, and it's normally closed, obviously, because we have current flowing. Okay, so the other switch I'll show you right now, right here. This one powers the relay. Okay, see, it goes on the positive of the 15-volt battery here, and it powers the relay. And it's connected on the other side, powering the whole electronic that triggers the relay. So here's the photo. So this one is, as you see here, pushed by this white rod. So this white rod has this teeny tiny screw. So this screw is the key, because this tiny screw actually engages the previous contact in this schematic SW4, and when relay is engaged, right, when there is overload mode, this little one, the relay gonna engage. Look, I'm gonna show you right now, demonstrate. So watch here. Relay gonna engage, this gonna pop, because this little teeny tiny screw actually butts close to the relay contact, and when it disengage, it just moves up. When it's pushed back by you, it again relay goes back in, and they are together. When the relay disengage, this shoots up. So now the funny part. Okay, so let me explain how this thing works. As you mentioned, so the first contact that I show you was this as switch 4, and the second one, which is right here, it's actually a little bit visible, this guy, is switch 3. Okay, so this switch 3, it's a bit better. It powers or turn power on and off to the relay. So in normal condition, a normal operation condition, a relay is powered, and this little rod is pushed down. This little floppy thing actually pushes rod upwards, the little springy, but it's not enough force to overcome the little tiny screw which makes contact with the relay switch. Okay, let me try to draw this because it's really hard to explain. So here's our relay in normally closed position. Here's the whatever magnet. Okay, so this is our white rod or button, and here's the tiny screw which makes contact with that one of the poles of the relay. So when the relay is engaged, so what's happened? It disconnects the circuit. Essentially, it turns like this. Okay. Okay, so it disconnects the circuit. Obviously, it disconnects the common from the rest of the circuit, and because this was engaged here, this thing will go flying, because that little springy leaf will actually push it upwards. It's from this way. So this is the screw. So essentially what's going to happen, and in the same time, that little contact will disconnect power to the relay. So, and this is something I do not understand, because at the moment you disconnect power to from the relay, it returns into this condition. Essentially closing back the circuit. So common now again is engaged through the terminal to the offending load. So I cannot understand why it's like that. So I would assume as long as relay, so I think relay should continue be engaged in this condition when those contacts are disconnected forever. Well, as long as there is a power applied to the relay, and only when you remove the overload condition that will engage common again, and you press the button, so this is probably something is not working in this guy, but at least now I understand that there is a you can tweak this thing. If you actually turn this teeny tiny screw too far in, that thing will never engage, because that screw gonna be in the way, right? So this is very important. I think this was the problem with this particular multimeter, that this screw was actually protruding too far, and this thing was never making a contact. Okay, I fixed that by tweaking this teeny tiny screw. Now it actually makes the contact, hence I can measure the voltage of this whatever battery. right? It actually shows 1.6. I think this, I need to tweak the multimeter, of course. Hello? Oh, it's wrong. Wrong leads. Yeah, this battery is 1.5 precisely, or almost precisely. This thing is a little bit overdoing it, but that's okay. That's okay, because if now I can go here, short those two, and now we can tweak our zero. So this is all working. So we can measure voltages on pretty much, well, not at 50 volt range, but I mean, there's something going on here, obviously. 10 volt range. Does it show what I think it's showing? Yes, it shows. But I mean, yeah. I can have to try to tweak, because look, it shows almost 2 volts, which is actually not correct at all. How about 50? Yeah. Well, it's more close 1.5 at 50 range. So yeah, I probably would need to tweak some ranges here. Yeah, I was using 250 as a reference range. Okay, so this kind of explains the problem with this thing. So this thing is actually works. Now I think I have to like tune it. So this is zero set, it's working. Now I have to tune the rest of it. And protection circuit seems to be working. Now I don't even understand what are these guys for. 1, 2, 3, 4. These 4 potentiometers. Also have to solder this guy back on, but this guy is only for the current range, and it is actually 0.47 ohms, and I think this is what it measures. Oops. Oh yeah, another interesting find. Look at this. So when you are in volt mode and you touch the shunt and the positive terminal of the 15 volt battery, you can test your protection. So this is the way you test protection on these guys. Touch the shunt, here the shunt, and the positive with your finger. That's it, or just use one finger right here. So, by the way, this particular 5P version quite a bit differs from the other one, because of this module is different, and this big ass capacitor here is completely absent in other ones. But it's not that of a big problem for me. Okay, so what next? Now I'm gonna figure out, probably gonna be part 2, because this video is already long. It took me some time to figure out things. Fix this one, measure it resistance, and solder it back on, and actually figure out what are these guys are from. So just to understand if they are the right, they properly tuned or tweaked or not. So essentially I have to calibrate this multimeter. So calibration of this multimeter is going to be probably in part 2, but at least the functionality is restored and it's actually functioning. Okay, so what I've done, also cleaned, as I mentioned, all these guys. Some of those relay contacts I slightly sanded with like 300 grit little sandpaper, like slightly lightly, just to make sure it's, you know, it has contact, because I had the impression it wasn't. Well, there was no contact. And where is the big ass battery? So I have also this battery, and in this case polarity is actually marked here. So this is for ohms range, and we can measure resistances. Obviously now it's going to be going all the way here. Just curious, on all ranges gonna go here, and that's it. It's milliampere ranges. Okay, let's return it back. Alright, so here we are. So essentially this guy is sort of working. Now I have to kind of test different voltages, test AC, and test currents. By the way, currents, as you saw with my resistor and I show you, is divider is working, so hence it full deflection in the on a meter movement. Okay, so part 2 gonna be calibration of this guy. I'm not gonna be doing so many crazy calibration, plus I don't have any high voltage sources to actually check, like, you know, 250 or 100 volt. Yeah, or sorry, 1000 volt, or not even 5000. There are a few problems here. Even if I want to, like, for example, use my back trap that I used to show you in my other video, I don't know what's the impedance of this guy, right? If input resistance of this multimeter is too low, it's just gonna load this high voltage circuit, and it's just not gonna do any high voltage things, because usually high voltage currents are very, very minute, so that thing may not just even work. So that's some specs I need to find. What would be the input resistance of this range? It's very important. So yeah, well, they have some 80 mega ohms resistors. Maybe that's gonna be fine. Well, I have to figure this out. All right, guys, I think that's gonna be it. I hope that video was useful, and we have similar problem with these coin multimeters. First of all, you know how to make MacGyver something to make 15 volt battery. All right, let me. Yeah, I don't have a marker here. Yeah. And then also, if you have issues with your protection, you would understand how it works. Sorry, it was kind of a convoluted way of getting here, but at least we know now that this guy is working, and part 2, you can calibrate it and probably use to measure some high voltages. I think, guys, that's gonna be it for now. Thank you for watching. Thank you for being with me in this long drawn video. I'm happy you stuck around. See ya next time. Stay tuned, stay safe, and ciao.